They should be super easy.
I just want you to know I didn't do that.
Okay. All right. So today we're using Trig to find missing sides and angles. Super easy day. And your assignment in Delta Math has a little bit of review from Thursday. So keep that in mind. So just as a quick review, what is our mnemonic for trigonometry? So-ga-doa. And I write it so like that. Ka-toa. And we also learned, just as a reminder, that if I wanted, this is sine, if I wanted cosecant of theta, cosecant is the reciprocal of sine, reciprocal split fractions. So H over O, hypotenuse over opposite. Secant of an angle is the reciprocal of cosine. So they have a C and an S combo there. And so secant would be what over what? H over A, hypotenuse over adjacent. So it's just the reciprocal, the flip of the fraction. And then cotangent is the only one that really makes sense all the time. And it is adjacent over opposite. So just as a refresher, those reciprocals are going to come up again in the last set of problems on today's work. So today our job is to look at the triangle that we've been given and figure out how to set up a trig equation. And so if here is my angle that I'm interested in, I know that x would be called the hypotenuse, and what would the 11 be called? Is it an A and H or an O? Opposite, yeah. It's the opposite side. So because I have the hypotenuse and opposite, which trig function can I set up? Sine, yep. Sine of my 32-degree angle equals opposite over hypotenuse. So 11 over x. And so every single one today, you're going to set up using those trig functions. The three big ones today. All right. And then how do we solve? You cross multiply. Yeah, we do cross multiply. And yes, that's the shortcut, which I'll talk about in a second. I'm going to multiply that x to the other side. I want to be pretty careful when you cross multiply that you're not confusing your calculator work here. This is x times the sine of 32 degrees. I want to be careful that you don't write like sine of 32x. This is improper notation and completely wrong, okay? Yeah, so if you wrote it sine of 32 and the 32 was captured inside the sine function and then you wrote the x, that's better. But still, it's not really a favorite. We typically write, when we multiply, we write things in front of sine functions. So this is really the best way to write it. So it's really clear. On the other side, we have 1 times 11, so that equals 11. And then I can, how do I get x by itself? Divide by the sine of 32. Which you all should have learned last year in geometry. Well, these guys. You guys hopefully already knew that from geometry. So you'll notice here what happened. The x and the sine of 32 ultimately just do a little swap, position swap. So you can see we started with 11 over x. And they really just, the x and the sine of 32 just position swap. So that is a shortcut. And you can just plug that into your calculator. What mode should your calculator be in? Degrees, yeah, why?
Because it's
degrees, yeah, they gave us degrees, so we should be in degrees. 11 divided by the sine of 32 degrees. Be careful on rounding. Yeah, so we could do 20.8 in this particular, oh, that's not degrees, sorry. So 20.8 units here, whatever length unit we have. Be careful in the delta math. They say round to the 100th or round to the 10th or round to the nearest degree. or nearest whole centimeter, or nearest inch, okay? In which case we want the whole, not the decimal portion. We want the whole thing. So read carefully. All right, let's look at number, let's do 3. So here we have this angle. Which sides did they give us? H and adjacent. And so which trig function uses adjacent and hypotenuse? Cosine. So we're going to write the cosine of our 23-degree angle is adjacent over hypotenuse. How do you get x by itself? Times by 30. Multiply that 30 to the other side. 30 times the sine of 23 degrees equals x. And this is just calculator work. Super easy. 30 times the cosine. Oh, I wrote sine. Cosine, not sine. We have a cosine function here of 23 degrees. And I get about 27.6 units of length here. Let's look at number 4. Here's our angle we're looking from. Which sides do we have info on? It's a tangent function. And we have opposite and adjacent sides, so that's a tangent function. So tangent of our 41-degree angle. Remember, you can't ever use sine, cosine, or tangent without an angle. That is the most important part. So watch your notation. Absolutely need an angle measure or a theta there. Opposite 15 over x, our adjacent side. And then how do you solve for x there? Cross multiply. And ultimately, they just do a little swap, don't they? So it'd be 15 over the tangent of 41. You can totally take that, you know, you could do it in 2 steps like we did here. Or you can just go ahead and do the little swap. All right, so this becomes 15 divided by the tangent of 41. And I get 17.3. Do you remember that?
Yeah.
Good? Super easy? Okay, great. So, that's to find side lengths. Now, we can do the similar thing to find angle measures. And we're gonna have to use inverse trig functions to find the measure of the angle. But the setup is the same, so I'll talk about that in just a second. So looking here at number 7, here's my angle. I'm trying to figure out what sides did they give me? The adjacent and the hypotenuse. So which trig function is that? Yep. So we're going to set up our cosine function. So now this is cosine of our angle theta, because we don't know what it is. So right now we want cosine of theta is equal to adjacent over hypotenuse. So 18 over 23. Now, right now, theta is trapped inside a cosine function. And yeah, so we need to do something to get rid of this cosine function. And remember, it's not multiplying. Okay, this is not cosine times theta. It's a whole function thing. And so what we're going to do is to cancel out a cosine function. To undo a cosine function, we use the cosine inverse. That's what this -1 means. It's the inverse function. So we're going to take a cosine inverse of both sides. And yes, I want you to smush it in. Mathematically, it's flawless. Okay? I want you to smush in the cosine inverse on both sides of the equation. Cosine inverse and cosine are inverse operations. They undo one another. And so now, because they cancel each other out, my theta has become free. It's no longer trapped inside the cosine house. And so in my calculator, I'm just typing in cosine inverse of 18 over 23. But again, you don't have to rewrite it. It's right here. You've already written it. You just have to do it on your calculator. So cosine inverse is a blue function, so second cosine inverse, 18 divided by 23. All right, so that becomes about 38.5. What's the unit on this? Degrees, yes, because we are finding an angle measure, so it is degrees. All right, number 8. Which trig? We're looking from this angle, so which trig function are we writing? Sine, yeah, because we have opposite and hypotenuse. So sine of theta is opposite over hypotenuse, 5 over 21. Right now that angle is trapped. How do we get rid of the sine function? Sine inverse. And you don't say sine to the negative 1 because it's not the same thing. This is notation. It's actually a word. Negative 1 is a reciprocal. So we just want to be very clear here. So my calculator, I just have to type in sine inverse of 5 over 21. Super easy. And I get 13.8 degrees roughly. All right, are you good with that, or do we need another? It's easy, right? Super easy. Like all this is review. So let's turn the page. Yeah.
When you do like sine inverse.
So it's in blue.
Oh, okay.
Yeah. So you got to do the second function, and then button. Yeah. Okay. So let's turn the page and go to solving right triangles. So solving right triangles means we need to find the measures of all 3 angles and all 3 sides. Find all 3 sides and all 3 angle measures. So there's 6 total parts that we need to find. We're not going to do too many of these, but just so you have seen this before. This is kind of interesting. I have one angle. Oh, I have a 90-degree angle. What else can I figure out? The last angle, how do we figure out angle B? From 180. So 180 degrees minus 72 minus 90. And we get 18. Okay. So that was easy. So we know that this angle right here is 18 degrees. Just subtracting from my 80. So that's good. Now we need to find the other sides. And so let's say I want to call this side X. First of all, I'm going to use the angle they gave me. Why am I going to reference the angle they gave me?
In case the other one's wrong.
In case I made a mistake on the other one. Absolutely. So I know 72 is correct. Now I want to figure out this X. And I have this 15. So this is the opposite side, and 15 would be the adjacent side. So which trig function can I set up? What uses tangent? So tangent of my 72-degree angle is opposite over adjacent. And then all I have to do is multiply that 15. So we get X equals 15 times the tangent of 72 degrees. 15 times the tangent of 72, and I get 46.2 is side CB, or BC, 46.2. All right, what if I want to find, I'm going to call this Y over here. You could use the Pythagorean theorem. But we could use cosine, yeah. So I'm going to use the trig function because the Pythagorean theorem is longer. But yes, the Pythagorean theorem we could do. So I can use, because this is a hypotenuse, adjacent hypotenuse, cosine of 72 degrees is adjacent over hypotenuse. So how do we solve for Y? So because I'm looking from 72, yeah. So I'm always going to use the angle they gave because it is free from mistakes. So I would multiply by Y and then the divide by the cosine. So it would turn out to be 15 divided by the cosine of 72 degrees? So 15 divided by the cosine of 72, we get 48.5 for that side AB hypotenuse. So pretty easy. But that's it. And using trig is the fastest way to do that. Do you have any questions? Right. Yep, that looks better.